Hello, good morning, good afternoon, good evening. Welcome to editions of Global Professionals Free Webinar. I would like to thank to all of you for this lovely event. Today, I'm going to host today's and myself from Bangladesh. My dear audience, um, my dear audience, I'm proud to be associated with IGP as a host this webinar. It's my delight to welcome you all to our institution free webinar. And once again, I'm thanking to all of you for joining with us. And before start from, I would like to request all of you please share this event in your timeline and with your friends, with your family member, with your also can know about this webinar and they can also get benefited from this session. Love invite all of you. Don't forget to share and don't forget to YouTube channel. We believe that power is gained by knowledge, not more. So you can also gain and you can also share from this webinar. Once again, I'm Nasri, member in IGP from Bangladesh. Every day we have some new participants give so let me give you a little concept about IGP. Of providing holistic social work and education for create a profession generation leading on online skill development institute with thousands of learners worldwide. We make it get able to use for every to face any circumstances and develop own skills. We are with international recognition. Institution of Global Professionals is an educational institution provides social work that it's not effective to increase one's skills just by acquiring formal education. So we provide effective training in the world. We organized our webinar, training, offline, online courses, etc. by players, coaches from all over the world to create a best platform, best learning platform for all of you. Our mission is to we already completed our 518 webinars and today I'm presenting webinar 19th and the topic is scientific research in mathematics. So before in let me remind all of you, please share this event and mention and tag your friends in our comments. Philippines. Welcome, sir, Dr. Chris.
Hello, ma'am. Um,
How are you,
can
sir?
can I share my screen now?
Yes, sure, sir.
Okay, ma'am. Can you see my screen already? Okay. Um, my talk is titled Scientific Research in Mathematics. By the way, I'm Dr. Chris L. Armada from Cebu Normal University, Cebu City. Okay, Philippines. Um, in um, this topic, I'm going to discuss to you about the 10 simple steps in writing scientific paper, and then I will give you an specific study in mathematics, which is in graph theory, and I will show you some of its applications. And then after that, I will show you an specific study, and then I will give you some specific results or samples. And then after that, um, I can teach you how to make some definitions for you to have your own scientific research. Okay, let's start. Okay, um, 10 steps in writing a scientific paper. Okay, number one, write a vision statement. So, what is the key message of your paper? So, be able to articulate it in one sentence because it's a sentence you'll come back to a few times throughout the paper. Think of your paper as a press release. What would the subhead be? So, if you can't articulate the key discovery or accomplishment in a single sentence, then you're not ready to write a paper. The vision statement should guide your next important decision. Where are you submitting? So, every journal has a different style and ordering of sections. So, making this decision before you write a single word will save you a lot of time later on. So once you choose a journal, check the website for requirements with regards to formatting, length, limits, and figures. Okay. By the way, um, to all who wants to have a good score for the quiz, so you can take a screenshot with this kind of backgrounds. So some topic without this background, it is not they are not included in the quiz anymore. Okay, so have some screenshots for this. Okay, next, number two, don't start at the beginning. Okay, what comes to your mind if if you hear that word? Don't start at the beginning. Okay, so logically, it makes sense to start a paper with the abstract or at least the introduction, but don't don't do that. You often end up telling a completely different story than the one you thought you were going to tell. So if you start with the introduction, by the time everything else is written, you will likely have to rewrite both sections. Okay, since for example you write now your paper, so after that your abstract there that contains the results of your paper. So what if you cannot obtain that result? So you have to rewrite again your abstract. Okay, that's it. So don't start with the abstract and the introduction. Okay, next, number three, storyboard the figures. Figures are best place to start because they form the backbone of your paper. So unlike you, the reader hasn't been living this research for a year or more. So first, figures should inspire them to want to learn about your discovery. Um, in my research, I didn't put some figures there. So after this, I will make some results with figures. Okay, next, number four, write the methods section. So, of all the sections, the methods section is simultaneously the easiest and the most important section to write accurately. Any results in your paper should be replicable based on the methods section. So, if you have discovered developed an entirely new experimental method, write it out in excruciating detail, including setup, controls, and protocols. Also, manufacturers, and part numbers if appropriate. So if you're building on a previous study, there's no need to repeat all of those details. That's what references are for. So in my study, I am not writing the methods section since, again, in the last part, there's no need to repeat all of those details if you're building on a previous study. Okay. Um, Next, number 5, write the results and discussion section. So in a few journal, results and discussion are separate sections. However, the trend is to merge these two sections. So that is the trend now. And this section should form the bulk of your paper by storyboarding your figures. You already have an outline. Okay, um, you can use this section to help readers understand how your research fits in the context of other ongoing work and explain how your study adds to the body of knowledge. So, this section should smoothly transition into the conclusion. Okay, step number 6, write the conclusion. In the conclusion, summarize everything you have already written. So that's it. Emphasize the most important findings from your study and restate why they matter. So state what you learned and end with the most important thing. You want the reader to take away from the paper again your vision statement. So, from the conclusion, a reader should be able to understand the gist of your whole study, including your results and their significance. By the way, in my papers, I didn't put some conclusion there. So, actually, it's okay. It depends on the publication in the journal that you are going to publish your work. Okay, next, number 7. Okay, here now, so after you write them already with your results and then with your conclusion, now you can write now the introduction. Okay, the introduction sets the stage for your article. If it was a fictional story, the introduction would be the exposition, where the characters, setting, time period, and main conflict are introduced. So scientific papers follow a similar formula. So the introduction gives a view of your research from 30,000 feet. It defines the problem in the context of a larger field. Um, it lays out your hypothesis, which may include your expectations about what the study will contribute to the body of knowledge. So, the majority of your references will be located in the introduction because you're going to cite them here in the introduction. Okay, next, number 8, assemble references. The first thing that any writer should do is pick a good electronic reference manager. So there are many free ones available, but often research groups or PIs have a favorite one. So editing will be easier if everyone is using the same manager. So later I will show you an example for this one for the references. Okay, next, number 9, write the abstract. So this would be the next. So the abstract is the elevator pitch of your article. So most abstracts are 150 to 300 words, which translates to approximately 10 to 20 sentences. So like any good pitch, it should describe the importance of the field, the challenge that your research addresses, how your research solves the challenge, and its potential future impact. It should include any key quantitative metrics. If it is important to remember that abstracts are included in search engine results. So that's it. The abstracts are included in the search engine results. So you have to write your abstract as clearly as possible so that when someone search for that, it can easily be searched. Okay, next, number 10. The title comes last. Oh, um, this is so different, right? So, um, again, if you're writing a paper, I thought when I starting to make a research, I thought that the title will comes first, right? But here the title should comes last. Okay, the title should capture the essence of the paper. So if someone was interested in your topic, what phrase or keywords would they type into a search engine? So what make sure your word those words are included in your title. Okay, that's it. Next, okay, the source for that is this one, the 10 simple steps by writing a scientific paper by Andrea Armani. Okay, that's the 10 steps. So this is the summary of what I discussed. Okay, next, the 7 parts of a scientific paper. So structuring research papers in APA style. So the APA means American Psychological Association. Okay, first part is the title page. So what is this paper called and who wrote it? So the first page of the paper. This includes the name of the paper or the title of the paper, a running head. So the authors and the institutional affiliation of the authors. The institutional affiliation is usually listed in an author note that is placed towards the bottom of the title page. So in some cases, the author note also contains the acknowledgement of any funding support and of any individuals that assisted with the research project. So I will show you an example of a title page. So that's it. Um, the title there is Forcing Domination Numbers of Graphs Under Some Binary Operations. And the authors are Chris L. Armada, me, yours truly. Okay, next, Sirio R. Connie Jr. and Carmelito Igo. And then the following are the affiliations of the three authors. So the first and the second author are from Department of Mathematics and Statistics, Center for Graph Theory, Algebra, and Analysis, Premier Research Institute in Science and Mathematics, Mindanao State University, Iligan Institute of Technology, A. Bonifacio Avenue, Tibanga, Iligan City 9200, Philippines. And then for the third author affiliation, Department of Mathematics, College of Natural Sciences and Mathematics, Mindanao State University, Main Campus, Marawi City. Okay, then as you can see at the bottom part, um, it says right that this is the author note, right? Okay. One, the research is funded by the DOST Astar DP NSC SRSF Philippines. Okay, and then by MSU Iligan Institute of Technology, Iligan City, Philippines, and then by Commission on Higher Education, Philippines. Okay, number two, the abstract. Okay, the abstract is usually at the first page of the paper, so you see it already. So one paragraph summary of the entire study. So typically no more than 250 words in length. So and in many cases it will shorter than that. So the abstract provides an overview of the study. So in that example, the abstract is here. So in this paper, we characterize the dominating sets in the join, corona, and composition or lexicographic product of two graphs. Further, we determine the domination number and forcing domination number of each of these graphs. Number three, the introduction. So what is the topic and why is it worth studying? The first major section of text in the paper, the introduction, commonly describes the topic under investigation, summarizes or discusses relevant prior research. For related details, please see Writing Literature Review section of this website. Okay, identifies and resolve issues that the current research will address and provides an overview of the research that is to be described in greater detail in the sections to follow. So example of the introduction is here. Okay, a small part of the introduction is here. Let G is equal to V of G, A of G, be a graph, and V is element in V of G. That's it. So the open. Okay, this is now the introduction, Now, as you can see, some of the references are here. They are cited here like this. The concept of domination and the other variations of domination may be found in the book by Haynes et al. Okay, in five. It is in the fifth of the references. Okay, and as you can see also here, the definitions of the top, some important definitions that will be used in the study. Okay, next. Number four, the methods. What did you do? To a section which details how the research was performed. It typically features a description of the participants or subjects that were involved. So the study design, the materials that were used, and the study procedure. If there were multiple experiments, then each experiment may require a separate methods section. So a rule of thumb is that the methods section should be sufficiently detailed for another research to duplicate your research. So in my paper, so as you can see, we don't have some participants to be to call this, what do you call this one? Um, we didn't this study is, we didn't use some statistics here, so no need for participants. So this is pure mathematics. So in here, what we are doing here in this type of study is we will create some theorems. After that, we will prove the theorems by direct proof or proof by introduction. So since that is the method already um, for this type of scientific paper that I'm going to show you the examples, the methods there are it is okay not to write the methods there. Okay, next, number five, the results. What did you find? So a section which describes the data that was collected. Okay, in my research I am not collecting data, and again, and the results of any statistical tests that were performed. It may also preface by a description of the analysis procedure that was used. If there were multiple experiments, then each experiment may require a separate results section. So here in our type of study, the results are again from the theorems that we can discover from the following graphs that we are studying. Okay, for example, this one for the join of graphs. Okay, this is the main results are here. So as you can see, there is an example here. A result is, this is a theorem 2.1. Okay, the theorem goes like this. So um, that is the example of the main results. So in here, we can find that there are two graphs, G and H. So then C subset of V of G plus H is a dominating set of G plus H if and only if at least one of the following is true. So that's it. C, number one, C is subset of V of G and is dominating set of G. Number two, C is subset of V of H and is a dominating set of H. And then C intersection V of G and not equal to MT, and C intersection V of H not equal to MT. And this is the proof. Okay, this is our how we do it in this kind of research. We perform some theorems and then prove that theorem. So if a corollary follows directly from that, no need to prove that one. So as you can see, corollary 2.2 has no proof. Okay, next, number six, discussions. What is the significance of your results? So the final major section of text in the paper. So the discussion commonly features the summary of the results that were obtained in the study, describes how those results address the topic under investigation and or the issues that the research was designed to address, and may expand upon the implications of those findings, limitations and directions for future research, and also commonly addressed. So here in my paper, I don't have some discussion. Okay, so after the results, the next part is the references. So next, number seven, references. A list of articles and any books cited. An alphabetized list of the sources that are cited in the paper. by last name of the first author of each source. Each reference should follow specific APA guidelines, including author names, dates, article titles, journal volume numbers, page numbers, book publishers, book locations, websites, and so on. Okay, I will show you an example for this. Okay, this one, Wicksted JT. Okay, Wicksted is the name of the author. 2004 is the date of the publication. The Psychology and Neuroscience of Forgetting. This is the title, right? The article title. Next, the Annual Review of Psychology. Okay, this is the journal. And then 55, this is the volume. And then 235 to 269 is the number of pages. Okay, in my paper, I follow this kind of format for the reference section. Okay, I start with the authors. So after the authors, the title of the article. Next is the journal, the name of the journal, the volume number, and then the year of the publication, and then the pages. Okay, it's okay to have that kind of um, reference. Okay, now let's go to the applications of graph theory because I will give you an specific example of a scientific research in mathematics, and that is under the graph theory. So, um, okay, for this one, no need to have some screenshots because this part it is not included in the quiz. Okay, but if you want to have some screenshot, it's better. Okay, graph theory is used in vast area of science and technologies. So this is the example of graphs. Okay, the circles there are called the vertex, and then the lines there are called the edges. Okay, in computer science, graph theory is used for the study of algorithms like Prim's algorithm and Krustal algorithms. Okay, that's the following use of the graphs. The graphs are used to define the flow of computation and then represent networks of communication and represent data organization and others. Okay, next. Okay, this is an example for that. Web page can be represented by a direct graph. The vertices are the web pages available at the website. Okay, this is an example for that. Okay, there is a person here. Is a friend of this one. So actually, Facebook is based in graph theory. Okay, next, networks. Graph theory can be used in computer networks for security purpose or to schematize network topologies, for example. Okay, that's it. So in here, they treat the vertex as the computer, and then they're connected with this line. This the edge. Okay. Here also, as you can see, this is a network of the applications. Facebook is here, the Twitter, okay, the YouTube, and others. Next, electrical engineering. In electrical engineering, graph theory is used in designing of circuit connections, and these circuit connections are named as topologies. So some topologies are series, bridge, star, and parallel topologies. So this is an example for that in electrical engineering. So this is the figure, right? This is used in in some of our electrical engineers, and then to convert this one into graph, from that A, okay, the graph version is this B. Okay, also here at the bottom, this is this one. They made this one, and then transforming this one into graph theory is that is the right one with the red one as the vertices, and then some edges are there. Okay. So in linguistics also, graphs are mostly used for parsing of a language tree, and grammar of a language tree. Okay, so this is the properties of words. Okay, so the words there in inside the rectangle, they treat this one as the vertices, and then the edges are here. Okay, so physics and chemistry, graph theory is used to study molecules. Okay, and etc. So here is the example for that. Okay, if you have this one and then convert this one into a graph and form this one, and that's in the right side. Okay, next is that's for physics, and then for chemistry, here the molecular graphs as an example. So next, in social science, graph theory is used in sociology, for example, to explore rumor spreading or to measure actors' prestige, notably through the use of social network analysis software. Okay, acquaintanceship and friendship graphs describe whether people know each other or not. Okay, this one, so social network modeled as graph. So we can have an edge if the two vertices or the two persons that represents the persons there represents the vertices. So if they are friends, so there is an edge between them, and then if they are relatives also, there is an edge between them. Okay, that's it. So social network modeled as a graph. Next, in biology, nodes in biological networks represent bimolecular such as genes, proteins, or metabolites, and edges connecting these nodes indicate functional, physical, or chemical interactions between the corresponding bimolecular. Okay, so example for that is this one. Are you familiar with the food web? I guess it is. Okay, next, in mathematics, operational research is the important field. So graph theory provides many useful applications in operational research. So that's it. So here we have some discrete mathematics and graph theory. This is a book um, that uh, that contains some studies in graph theory. Okay, and now we are going to have now the specific study for graph theory. So this is the forcing domination in the join of graphs. Okay, um, there is a lot of dominations in graph theory. So, for example, there are some inverse domination, connected domination, total domination. So, in there, you can take the forcing of any of that. So, any of the dominations that are already published. So, if you, for example, you find an a domination such that um, uh, they did not study its forcing. So what you're going to do is to get the forcing of that one. So for example, you find the inverse domination, and you will make a study um, for that, so you can have the forcing of that. So forcing inverse domination. But if you can search the forcing inverse domination already in the Google, so just look for what graphs they considered in their study, so that your study will not be or will not have some complications or conflict to the other studies. Okay, now introduction. Okay, by the way, this is very easy if you know graph theory. So first, let G be equal to this one, V of G, E of G. Okay. The V of G here denote the vertex set. So the set of all the vertices. And then the E of G is the edge set of G, or the set of all edges. So the graph that are considered in this study the graphs that we considered in this study are simple and undirected graphs. Okay. For the definition of the domination number, we are going to use the closed neighborhood. Okay. The closed neighborhood, okay, this one, N of V in G of a vertex V of G is the set consisting of V and every vertex U such that UV is element in the E of G. So um, in here, you have to understand the definition of the domination that you are studying. So that if you take its forcing, it is very easy for you to get the forcing domination number of that. Okay, so next, any S subset of V of G is a dominating set in G. It means that the set S is contained in the V of G. It is a dominating set in G if the union of all the neighborhood of V in G such that V element in S is equal to the V of G. So in here, for example, you have a graph. Okay, now if you pick a vertex, that is a vertex V, for example, if that if that vertex is connected or is adjacent to all other vertices in G, then that vertex V is part of the dominating set in G, or that is actually the minimum, right? Because it contains only one vertex. So here, the minimum cardinality gamma of G of a dominating set in G is the domination number of G. So any dominating set S in G with the absolute value of S, which is equal to the gamma of G, is referred to as a gamma set in G. So we will continue this one. Okay, now to understand that clearly, we have an illustration. So consider the graph G here. Now, um, can you find a minimum number of vertices such that the other vertices, all other vertices are adjacent to it? Okay. Now, if I colored red the vertex B, now as you can see, the other vertices are adjacent to it, right? Yes, it is. So all of the other vertices are adjacent with B. Okay, by definition, this is now our gamma set. So the set S that contains the vertex B is the only gamma set in S. So you can label any set here. You can put uh, R, for example, or capital T here for the set that contains the B, the vertex B. And now since it is dominated, since the graph can be dominated by one vertex. So gamma of G is equal to 1. So this is the domination number. To get the forcing, we should get first the domination number. So in this type of study, you have to get the domination number. Okay, so for example, you are studying an inverse domination number. You want to get the forcing of that. So step one, you should get the inverse domination number of the graph. Okay, so that you will know it. So after that, now we can define the forcing domination number. So let S be a gamma set of a graph G. So in here, this one, you can change this one, the gamma set here in the definition. So if, for example, your domination is connected domination. So for the connected domination, um, the gamma there, that they use the gamma C there, gamma C. So in here, you are going to replace the gamma, all of the gamma. So gamma, this becomes gamma C, and then this is gamma C. The gamma here should be gamma C also, and then this one, the gamma here. So all of the gammas there, replace it with gamma C if your study is about the connected domination. Okay, so let S be a gamma set of a graph. So a subset D of S, so no need to change this one. A subset D of S is said to be a forcing subset for S if S is the unique gamma set containing D. So in this sentence, what we're going to change there is this gamma. So if you have gamma C set, so we have gamma C set also here. Okay, so I am telling you this to for so that you can define your own forcing. Okay, next, the forcing domination number of S is given by this one. F gamma of S is equal to the minimum of the cardinality of D such that D is a forcing subset for S. The forcing domination number of G is given by this one. F gamma of G is equal to the minimum of the F gamma of S such that S is a gamma set of G. Okay. For example, if you want to get the forcing of the inverse domination, all you have to do is to insert in inverse here. So the forcing inverse domination number of S, for example, here is given by F gamma. The the inverse is denoted by gamma prime. So we can have F gamma prime S is equal to the minimum of the cardinality of D such that D is a forcing subset for S. And then the forcing inverse, you can insert inverse here. Forcing inverse domination number of G is given by this one. You just have to change this one, the gamma here, to gamma prime. Here's one gamma prime and then gamma prime here. If you are going to define the forcing inverse domination number. Okay, next illustration. Now, how to get the forcing of a graph? So consider the graph G here. Okay, the gamma of G is 1. Since we're going to get the forcing domination, so we will consider the gamma of G, which is equal to 1. Now, set S is equal to the set containing B is the only gamma set in G. So if this is the only gamma set, what are the subsets of this set B? So that we have first the subset are empty and then the set containing B. They are forcing subsets for S. Now, um, since we are going to get the minimum, which of the two contains the minimum cardinality? It's empty, right? And then the cardinality of empty is 0. Thus, F gamma of G is equal to 0. So if your study is about forcing inverse domination, for example, if you can get only one gamma prime set in that graph, then clearly the forcing domination number is equal to 0. Okay, since the minimum cardinality here is empty. Empty is the forcing subset for that set. Okay, next, consider the graph H. Okay, if this is our graph H, okay, the gamma of H here is equal to 2 because as you can see, none of the vertex, a single, what do you call this one? We cannot find a vertex such that they are adjacent to all other vertices. Now we have to pick, if we pick D, we have to pick another vertex because J and A and G are not adjacent with D. So we pick C here. So we have DC. So as you can see, all of the other edges, oh no, all of the other vertices are adjacent with them, right? And also we can pick IC, right? So we have IC also here. So all the other vertices are there adjacent with I, also in C. Okay, so we have this one. Now we have two sets only. Um, the set containing I is uniquely contained in S, right? And then the set containing D is uniquely contained in C. So we cannot use C there because C is contained in the two sets. Okay. So since they are uniquely contained in that sets, so this one, the set containing I is a forcing subset for S. And since this is the minimum, so F gamma of S is equal to 1. Now, the set containing D is uniquely contained in T. So this one is a forcing subset for T. So F gamma of T is equal to 1. Now, why empty is, as you can see, empty is not considered here as a forcing subset. Why? Because empty is contained in all of the set, right? It is contained in S and it is also contained in T. Note that an empty set is a subset of any set. So it is a subset of S and it's a subset of T also. So the empty here is not considered as a forcing subset. Since the F gamma of the two sets are both equal to 1 and we're going to get the minimum of this one, which is in the definition, hence F gamma of H should be equal to 1. Now this is the theorem for that. So let G and H be connected graphs, then C subset of V of G plus H is a dominating set of G plus H if and only if at least one of the following is true. So I, C is a subset of V of G and is a dominating set of G. And 2, C subset of V of G and is a dominating set of H. And then 3, C sub intersection V of G is not equal to empty. And C intersection V of H is not equal to empty. Now for the join of graphs, what they're going to do here is this. If you have a graph G and then a graph H, okay, to construct the join, all you have to do is each vertex in G should be adjacent to all vertices in H. So all you have to do is to add some edges. Again, any vertex in G should be adjacent or to be adjacent in all vertices in H. So if we have two vertices in G and then we have two vertices in H, so how many edges that we're going to add? So we have to add four edges. So since a vertex here in G should be adjacent to the two vertices, then another vertex here it should be connected or adjacent to the two vertices in H. Now, corollary 2.2. Let G and H be connected graphs. Then the gamma of G plus H is equal to 1 if the gamma of G is 1. So if the gamma of G is 1, it means that the graph it can be dominated by one vertex, right? So this is an example. I show you already an example for this. Okay, it means that there exists a vertex such that the other vertices are adjacent to it, right? Or the gamma of H is equal to 1. And then the gamma of our G plus H is equal to 1. Next, if our gamma of G is not equal to 1, if both of them are not equal to 1, then the gamma of G plus H is 2. So where is this? Um, since we're going to construct the join, so for example, if the graph G and the graph H can be dominated by one vertex, if we if we make the join of that graphs, also that graph can be dominated by one vertex. But if not, if both of them cannot be dominated by a single vertex, so what they're going to do is to get a vertex in G and then a vertex in H. Why? Because if you get a vertex in G, that vertex is adjacent to all vertices in H, right? And also, all vertices in H, any vertex in H actually, is also adjacent to all vertices in G. So if you pick one in G and then one in H, one vertex in H, it can dominate the whole graph since they are adjacent to the other vertices in G plus H. Okay, now theorem 2.3. So let G and H be any two graphs with gamma of G is equal to 1 or gamma of H is equal to 1. So this is in our first case here. Okay, that is why you need the gamma, the result for the domination number. This is the domination number of the G plus H. So to get the forcing, this is the first step. You get you should get the domination number. So there are a lot of domination numbers published already. So if you take the forcing, you have to uh, get them. Okay. Next. Okay, now to get the forcing, we have here. Okay. Then f gamma of g plus h is equal to 0. It is 0 if our gamma of g is 1, the gamma of h is not equal to 1, and g has a unique gamma set. So it means that if our graph G can be dominated by one vertex, okay, right? And then the gamma of H cannot be dominated by one vertex. So, and G it has a unique gamma set. So if G has a unique gamma set, so we can have a unique vertex in G such that it can dominate the whole graph, right? And since after that, we can if that is a unique gamma set in G, it is also a unique gamma set in G plus H. Okay. Okay, I told you already if we can have the unique gamma set, our forcing there should be 0, right? Since the minimum cardinality of the forcing subset for that is 0, since empty is the forcing subset for that set, right? Okay, now um the second case is just the reverse for the first case. So we have to change the G there with H, and then the H change with G, and then the G here change with H. So that is the gamma H is 1, the gamma of G is not equal to 1, and H has a unique gamma set. So this one is similar to the top case. And then one otherwise. So the otherwise part, okay, what is in the other part, in the otherwise part? So in the otherwise part, if both of them gamma of G is equal to 1. Now, if both of them uh contains the gamma of the graphs is equal to 1, if both of them are equal to 1, so we have a sub is set here, a gamma set in G and also a gamma set in H. Both of them are gamma sets in G plus H. Now, if that contained one vertex and then the other one contained a one vertex also, okay, so what will happen? Empty is not a forcing subset because empty is contained in the two sets, right? But now after that, if empty um, is not the forcing, it is automatically that the forcing is equal to 1 since the gamma is only 1. Okay, now what is the upper bound for this forcing? Okay, I didn't tell you that already. Okay, um if the domination number is 1, your forcing is either 0 or 1 because the forcing is less than or equal to its domination number. Okay. So if the gamma of G plus H, for example, is 2, so the possible forcing is 0, 1, and 2 only. So you cannot what do you call this one? You cannot go beyond with the domination number. So you cannot go beyond with 2 if the domination is 2. So in here, since the gamma of G is equal to 1 and gamma H is 1, using our corollary, the domination number or the gamma of G plus H is only 1. So the forcing is only 0 or 1. Okay, so that's it. Only 0 and 1. So that will be the result. So next is, okay, this one. For any graph H, the f gamma of k1 plus h is equal to 0 if gamma of h is not equal to 1, 1 if gamma of h is 1. So where I get this result, I get that one from here. So if we replace G here with K1, that is the trivial graph, or that is a vertex with, that is a graph with one vertex only and no other edges, only one vertex with no edges. Okay, if that's it, plus a graph H, so it means that that vertex is adjacent to other vertices in H, right? In constructing our join. So in here, as you can see here, for example, this vertex is adjacent to all vertices here at the top. Okay, so this is, for example, this is our K1, and then this is the graphs for H there at the top. Okay, also in here, if our K1 is here in the center, and then our H is this cycles. Okay, and then to construct the join, all you have to do is to add some edges to the other vertices. Okay, that's it. Now, if we replace K1 there in G, so if this is K1, so the gamma of K1 is 1 already, so we have to remove this one. And then G has a unique gamma set. Clearly, K1 has a unique gamma set, so no need to write this one. So the remaining case should be gamma of H is not equal to 1. So that's it. It is 0 if the gamma H is not equal to 1. And then 1 if gamma H is 1. Where I get that? This is in the otherwise part because this is 1 if both gamma of G and gamma H is equal to 1. Okay. So that's it. And then you can clearly also see here the forcing. So for example, it is 0. Where can we find the 0 here? The 0 forcing. Okay, for example, the W6, okay. Imagine the W6. Okay. As you can see, this graph can be dominated by one vertex in the center. Now, so that is a gamma set of K1 plus H. For example, if this is our K1 plus H. So this vertex can dominate the whole graph. Now, as you can see, no other vertex can dominate all other vertices. Hence, that is a unique gamma set. Now, I told you an example already that if the gamma set is unique, the forcing is 0. But if the gamma H is 1, okay, look at W3. This is a C3 or a triangle if you can imagine. Okay, K1 there in the center. Okay, the gamma of H there is 1, right? Because in the triangle, that is, this graph can be dominated by one vertex. If you choose this vertex, it is connected, it is adjacent with the other vertices. Okay, now, um, this is the graph here. Okay, now this is one. Um, this vertex in the center is a gamma set, and also the other vertices there. If you write that one in a set, then all of them are gamma sets in F gamma of in gamma of K1 plus H. So if there are gamma sets there, now what is the forcing? Again, since there are a lot of gamma sets for the gamma sets there should we have four gamma sets there. So since that is not unique, it should not be zero, right? So no other choice since that vertex can be dominated by one vertex. The answer for the forcing is 1, right? Because if you pick this one as vertex A, so this A is contained in that set only, right? So that's uniquely contained in that set, and that is now the forcing for that. So the forcing for that is 1. Next, corollary 2.5. So let n and m be positive integers such that n is greater than or equal to 2 and m is greater than or equal to 3. Then the forcing of the domination number of fun. This is the fun graph Fn. So here we have the fun graph there. So this is a corollary that follows from corollary 2.4. Since the graph of Fn and Wm are equivalent K1, so our Fn there are the fun graph, if you can search that one, that is equivalent to a K1 plus a path graph. And then for the wheel graph WM, it is a K1 plus the cycle graph CN. Okay, so that replaces our H there in our corollary 2.4. So now if we have a fun graph, okay, Fn, it is 0 if n is greater than or equal to 4, right? So as you can see here in 4, only one vertex can dominate the whole graph in F4, which is this vertex here at the bottom. And then for the F5, only one vertex can dominate the whole graph at the bottom, the vertex here at the bottom. Now, one otherwise. So now for F3 and F2, we can find that if this is our vertex here, F3 is a gamma set. Also, this vertex in the center is also a gamma set, right? Because this vertex is adjacent to all other vertices in F3. And also in F2, if you pick this vertex as a gamma set, also these two vertex here are gamma sets in F2, right? If you pick this vertex, a single vertex here and a single vertex here, they're adjacent with the other vertices. So the forcing for that is 1. Okay, now, theorem 2.6, let G and H be any two graphs such that, okay, for now, if the gamma of G is greater than or equal to 2 and the gamma of H is greater than or equal to 2. So now, if both of the gamma of G and the gamma of H are greater than or equal to 2, then the forcing for that F gamma of G plus H is equal to 2. So this is the case for here. The gamma of G plus H, this is the case 2 here, the case when the domination number is equal to 2. Our gamma of G is not equal to 1 and gamma of H is not equal to 1. So it means that if it is not equal to 1, it should be greater than or equal to 2, right? Since the domination number is a positive number or a positive integer or a counting number. Okay, next. That's it, it's 2. So now this is some results. Corollary 2.7 for a complete bipartite graph K and M. So we have the forcing for that is 0 if n is 1 and m is not equal to 1. So to construct the complete bipartite, this is very easy. Okay, k and m. So all you have to do, if we have n vertices here, so that vertices are not connected with each other, or a graph with no edges. So we have because complete bipartite graph k and m is equal to an empty graph kn plus empty graph km. So as you can see here, K2, 3. So this is the vertex for K2 at the top, and then vertices of the K3 here at the bottom, empty graph. So after that, performing the join, all you have to do is to to make some edges such that any vertex here at the top should be adjacent to other vertices there at the bottom. So this is now the join for that, or which is equal to the complete bipartite K and M. So if you want to study for the complete bipartite also, you can search this one in the internet. So how to construct this graph. Okay, now, if our N is 1 and M is not equal to 1, then the forcing is 0, right? So if we have one vertex here and then M is not equal to 1, it means that only one vertex can dominate the whole graph. And then only one gamma set also, so that is why our forcing there should be 0. And then, or M is equal to 1 and N is not equal to 1. Similar, this is similar to this one. Okay, next, if both of them are equal to 1, the forcing is 1. And then if both of them are greater than or equal to 2, the forcing is 2. Okay. Next, for the generalized fan graph, this is for the generalized fan graph k n bar plus p m, where n is greater than 1 and m is greater than or equal to 2. The forcing are this one. This is 0 if m is 3, 1 if m is 2, and then 2 if m is greater than or equal to 4. And then for the generalized wheel graph, okay, this is equal to 1. The forcing is 1 if m is equal to 3, and then 2 if m is greater than or equal to 4. So in here, we consider n is greater than 1. So it means that an integraph k2 is the minimum plus cm. So all I have to do is to get another vertex here, and then it should be adjacent with the other vertices in the cycles. Okay, that's how to construct for the generalized wheel graph. So next, this is another study. So um, again, okay, now if we will be considering another domination, for example this one, inverse domination number. So I will teach you how to make the forcing for this one. So let D be a gamma set in a graph G. So this one um is a definition that I get from a previous study, which is inverse domination number. Then and after that one, I get the results for the inverse domination number, and then after that I get its forcing. So they study the inverse domination, and then I am studying now for the forcing inverse domination number of the graph G. So here, let D be a gamma set in a graph G if the V of G set minus D contains a dominating set D prime of G, then D prime is called an inverse dominating set with respect to D. So the minimum cardinality of an inverse dominating set is called the inverse domination number of G and is denoted by the gamma inverse of G. Now let S be a gamma set in G. So any inverse dominating set S prime with respect to S with the cardinality of the S prime is equal to the gamma prime of G is referred to us as a gamma prime set in G, and also S prime is a gamma set in either G or V of G na set minus S. So such definition was first introduced by V.R. Coley and S.C. Sigarkati in 1991. It may be noted that PJ Bhatt and SR Bhatt in 7 made mentions of its application in an information retrieval system. It can be readily verified that the gamma of G is less than or equal to the gamma prime of G. So this definition, I get that one in an this is part of an introduction, and then I just copy that one for for the definition of the inverse domination. Now, how to get or how to define the forcing inverse domination number. Okay, this is it. As what I told you earlier, we have to replace the gamma there, the gamma set in the forcing, in the definition of the forcing. So now, let S be a gamma prime set of a graph G. Okay, so this definition, I am the one who made this definition. This is based on the original forcing domination number. So in here, look at what I have just changed. So this here, let S be a gamma prime set of a graph G. So a subset B of S is said to be a forcing subset for S if S is the unique gamma prime set containing D. So as you can see, the gamma set in the first definition, I use the gamma sets there for the forcing. Now, the forcing inverse domination. Okay, here as you can see, I inserted the inverse already here. So forcing of the inverse domination number of S is given by F gamma prime of S, which is equal to the minimum of the cardinality of D such that D is a forcing subset for S. So the forcing inverse domination number of G is given by this one. F gamma prime of G is equal to the minimum of the F gamma prime of S such that S is a gamma prime set of G. So if you can find another variation on domination, for example, if you can have secure domination, if you can find that one, you can define the forcing secure domination number of the graph G. Okay, just that definition should be similar with this. All you have to do is to replace the gamma sets, the gamma there. So if they use gamma C, so replace this one with gamma C, this one, and then insert here. So that is forcing. I have forcing inverse domination here. Okay, if we have forcing secure, so replace this inverse with secure. So forcing secure domination number. Okay, now try to find some domination and then define your own forcing. Okay, and that's it. Thank you for listening. Um, now, try to make your own scientific research in mathematics. Thank you.
Thank you so much, sir. Thank you for sharing your presentation with our participants.
Yes,
So, you
you're
wanna
welcome,
say to our audience?
ma'am.
Do you wanna say anything to our audience, sir?
Okay, ma'am. Um, um, for now, if um, if you can get some results in what you construct. For example, if you make some forcing of another domination, so if you can have some results, be sure that your results is correct. Even if you don't have some proof for that, if you are not familiar with the proving part, because in here, so after you get the results, you have to prove that, since this is a scientific research. So after you prove that, all you have to do first is to read some books on graph theory and then some forcing dominations. Okay, you can search that one in the Google, some forcing domination, and then my last name, forcing domination armada. Okay, I have some results there for the forcing domination. I have some forcing domination. I have forcing independent domination. I have forcing connected domination, forcing total domination number, and then forcing DR power domination, and then forcing total DR power domination. So there you can practice some proof there, or you can have some readings about forcing so that you can make your own. And that's all, ma'am. Thank you.
Thank you so much, sir. So we will come back once again with you in our Q&A session. So till then, stay with us, sir.
Yes, ma'am.
Thank you, sir. My dear lovely audience, we will start our quiz competition session, so get ready for it. And before starting, please let me remind all of you, share this event more and more and stay with us. Welcome everyone in this lovely evening and thanks for joining with us in this event. So please share this event in your timeline and mention your friends in our comment box. And let me tell you about the program. You can see the joining link in our comment box, and you can also see the joining link that is www.slido.com and that flashed on our screen, and the code is IGP. So give the code and you can enter this session. You can also scan the QR code that is flashed on the screen. Okay, we have 13 participants who join with us. Now we have 17 participants. Please give your full name, which is screened in directly in certificates. Still, we have 17 participants. One more participant joined us. Now we have 21 participants. Those who were those who are new in this session, please go to our comment box. You can see the joining link and join with us and give the code, and that is IGP. have 24 participants right now. Today we'll declare top 10 winners' name. One more new participants join with us. So we have right now Melinda, Abed, Charlene, Kiefer, Remy Jiu, JB, Ashok Kumar, Vanarenda, Jerome, Brian, Abed, Trixie, Esther, Rosie, Maria, Mean, Lee, Facunda, Christina, Jemeline. Let's start the show. Our first question: which of the following statements doesn't belong to the 10 simple steps to writing a scientific paper by Andrea Armani? Is this write a vision statement or write a mission statement? Correct answer is write a mission statement. 56% gave the right answer. So we have Christina Vidal Rosario on first position in our leaderboard. Let's see our question number 2. Which of the following statements is one of the 10 simple steps to writing a scientific paper? The title comes last, or do not write conclusions. Let's see the answer. Okay, the correct answer is the title comes last. 79% chosen the correct answer. We have Sherilyn on first position in our leaderboard. Next question. Blank is the elevator pitch for your article. It is composed of 150 to 300 words, which translates to approximately 10 to 20 sentences. Is this title or abstract? Fill the gap with the answer. Okay, the correct answer is abstract, and 100% of our participants choose the correct answer. We have Sherilyn on first position, then we have Rosie on second position, then we have Alex on third position, we have Lee on fourth position, and Ricky on fifth position. Next question. The blank should capture the essence of the paper. Is this title or abstract? So the correct answer is title. 100% once again chosen the correct answer. Congratulations to all of you. Next question. What summarize everything you have already written? Is this conclusion or reference? So the correct answer is conclusion, and 96% of majority chose the correct answer. Congratulations, all of you. Next question. All of them are included in the 7 basic pillars of scientific research in APA style except what? Is this title page or literature review? Correct answer is literature review. 67% choose the correct answer. Okay, congratulations to all of you. Next question. What is an alphabetized list of the sources that are cited in this paper? Is this abstract or reference? So the correct answer is reference, and 100% of our participants choose the right answer. Congratulations, all of you. Let's see our question number 8. What does APA stand for? Is this American Psychological Association or Ancient Psychological Association? So the correct answer is American Psychological Association. 92% of majority choose the right answer. Congratulations to our winners. Let's see our question number 9. Which of the following statements is one of the 10 simple steps to writing a scientific paper? Don't start at the beginning or start with the conclusion. Choose your answer. So, the correct answer is don't start at the beginning. 50% of our participants choose the right answer. Congratulations to the winners. Let's see our question number 10, and it is our last question. Write a vision statement is one of the 10 simple steps to writing a scientific paper by Andrea Armani. Is this true or false? So the correct answer is true. 96% of our participants chose the correct answer. Let's see who placed in our top 10. Congratulations. You can see Charlene on first position in our leaderboard. Then we have Christina on second position. Then we have Evelyn Perry on third position. We have Carmela on fourth position. Then we have Ricky on fifth position. Then we have me placed sixth position. Then Rosie placed seventh position. Then Alex placed 8th position. Then we have Kiefer placed 9th position. And finally, we have Lee placed on 7th position. So congratulations to all of our top 10 winners. And thanks for participating, my dear lovely audience. And the winners, you get your certificates on our Facebook page, the quiz certificates. So get ready for our next session with our speakers, that is QA session. So before that, let me tell you once again, don't forget to share, tag, and mention your friends. And please share this webinar as more as you can. So get ready for next session and ask your question to our speaker. Welcome, sir. Welcome once again in our Q&A session.
Hello, ma'am.
My dear participants, please ask your question at today's topic in our comment box and please address our speaker's name. And we are waiting for your question. Okay, we have our first question from Mary Juliet. What is the importance of your research to fight or to lessen the bad effect of COVID-19 pandemic to the world today?
Um, Good afternoon. Actually, I am thinking of an application for my research in COVID-19. But as of now, I still cannot relate um what do you call this one? My topic in this kind of area, which is in the COVID-19 pandemic. So um I have some applications in my research, but it is not connected with the COVID-19 pandemic. Okay, can I just share that application or not? If you want, I can share that application. So, can I share that one so that they will know also the importance of my research? So, it is not connected with the COVID-19, but okay, for example, since I am talking about domination, hello, can you hear me? Okay, since I am taking about the domination number. So for example, if you have a community, okay, for example, if you have a community and then there is a network that can what they call this one that should observe, for example, can observe the vertices in there. So for example, that's a network, and then um there is something you should install, for example, in their houses. For example, the vertices there are considered as the houses. Okay, so if there is a wire that can connect so the other house, so that would be the edges. Okay, um wait. So after that, um what they call this one, there is a PMU which is very expensive that can be put in a house, for example, in a certain house, such that we can get its minimum number of that PMUs can be installed in that houses such that all of them are can be monitored. Okay, so that is now for the domination. So we get the minimum number of that since that is very expensive. So it should be in minimum. So after that, what is the use of the forcing? Now, what is the application for the forcing? Um, for example, if that PMU is very difficult to replace, for example, it takes time to replace that one if for example that PMU is what do you call this one? It gets some damages or it is not functioning, and then um so if it takes time to replace that, and it takes time also to replace that, so all we have to do is to install another PMU in another house, right? Okay. So if the forcing domination number is equal to its domination number, so that is F, for example, F gamma of G is equal to the gamma of G. Okay, because that is the what do you call this one? That is the most, or that is the most appropriate number, because if that is the forcing, it means that any of the vertices or any of the house which is near that one can replace that. So we can replace that PMU in another house. Okay, since um so the time that will be consuming is the installing part. So if it is difficult to replace that, because if you were going to replace that, you're going to get that and then install another one. So now we're going to do the what do you call it, the application of the forcing is we are going to install another in another house that PMU such that it can observe already all of the other vertices, since um that PMU, if okay, wait, I will explain to you um what is the work of that one. Okay, it's here because I cannot memorize it. Okay, 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 this is it. The graph there represent the electrical power system. So that's it. That is why I am referring to some wires there. So where the vertex represents the an electrical node and an edge represents the transmission line joining two electrical nodes. So some measurement devices must be placed at selected locations so that all the state variables of the system can be measured in order to monitor the power system. So a phase measurement unit, or PMU, is a measurement device placed on a vertex, so that would be the houses, and has the ability to measure the state of the vertex and the edges connected to the vertex. So the vertices and edges that are measured by PMUs are said to be observed. So in this study, it is necessary that each vertex with PMU is adjacent with another vertex with PMU also. But because of the high cost value of the PMU, it is desirable to minimize their number while maintaining the ability to monitor the entire power system. So that is why if our forcing is equal to its domination number, it means that we can install um, a PMU in another vertex such that we can it can be monitored the power system again in what do you call it, in just a shorter period of time, since it is given that it takes time to replace a PMU. Okay, that's it.
Thank you,
Thank
sir.
you so much.
Next, we have any question or let's see.
By the way, you can read that importance of my research or the application for that in my Forcing Total DR Power Domination. You can search that one in the internet.
Still waiting. Dear audience, if you want to ask question to our speakers, please go to our comment box and address our speaker's name and ask your question. So, read some comment. Ikea Tutari is brilliant. Or another participant said great. Okay, we have question again from Mary Juliet. How can we teach the love of research to our primary students?
Um, how can we teach the love? Okay. First is um, what do you mean by primary students? Are there what grades are they are them from the primary schools or the what do you call this one? The elementary students, I guess.
I guess so, sir.
It's not for the um um for 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 elementary students, I guess the research is not that their area. Okay, so I guess the research may start in what they call this one. There's some because there are so many types of researches. Okay. It depends on in the age of that. For example, okay, I'll just have to answer this. How can we teach the love of research to our primary students? So if you start, I guess you're going to give them first, for example, some applications of the researches, the good applications of research, and then um, you take, for example, some research, for example, not related in mathematics, right? So you can have some um, researches under what type? For example, some researches on engines. You can share that one to them. Okay, and then after that one, their applications of that research. Why is it very important to conduct that research, and then its applications in real life so that they can be inspired to know that, oh, the students will have to get inspired if their applications is very very useful to the community, for example. So cite some researches um, that contains a lot of examples or a lot of applications in real life so that they can appreciate or love the research. Okay, that's all.
Thank you so much, sir. Thank you for sharing your brilliant presentation with our participants. Thanks once again.
You're welcome, ma'am. Thank you so
Have a
much
good,
for the opportunity.
have a good day, sir. my dear lovely audience. Today's program name is Scientific Research in Mathematics and the code is IGP 6454. Once again, I'm repeating the code is IGP 6454. So without code, no one is eligible for certificates. With code, you can claim your certificates anytime, or you can go to our website, and the address is www.eduigp.com. So go to our website address, get your certificates, and celebrate with us. Celebrate your happiness and share with us. Till then, stay happy, stay healthy, stay blessed. Have a good day to all of you. Thanks for staying till the end of our program.